Good evening, members. On behalf of the SIRC of ICAI, I welcome you all for this CPE meeting on a very, very important topic, a topic which is taking a lot of discussion these days, which is the future on databases, big data. Today we have with us one of the most eminent person with us as a speaker, a fellow member of the Institute of Chartered Accountants of India since 1981, on the board of governors of the Institute of Internal Auditors, and currently heading as the president of the Chennai chapter. His assignments include internet security, system design, system architecture and technology design, information systems audit, forensic audits, data migration audit, CAT audit, enterprise risk assessment, fraud risk assessment, data analytics, data visualization, standards compliance, ERP architecture design, infrastructure management services, cyber law compliance, software remediation, and IT or IS related regulatory compliances like SOX, SOX-J, JSOX, and EuroSOX. A guest faculty at the University of Madras, in the Institute of Chartered Accountants in India, and also the Institute of Management and Research, IIT Madras, and various colleges in the city of Chennai. With these words, he has handled assignments also internationally in USA, Malaysia, and Sri Lanka. With these words and some words which we've heard, like cyber law compliance, data analytics, gives me great pleasure to introduce the speaker of the evening, CA Dr. K. Paul Jayakar, MCom, FCA, DIRM, and PhD, CRI, CRIS. Sir, the session is over to you.
Well, thank you so much. I'll get started. I'll just open the presentation. Thank the SIRC for the opportunity to speak, and thank you very much for the introduction, all this team who's making all this possible, and all our participants. Of course, questions will be handled by the team, and end of the session, I'll answer all your questions. I'll start off the presentation. We are starting with the first one, which is the SQL, or what we call structured data language. That's the presentation we are starting with. The screen should be visible. I mean, if it's not visible, please let me know.
Visible, sir. It's visible, sir.
Right. So I'll get started. I'll just turn off the camera for the moment till I come to the end of this session. There are two sessions. This is one, and big data is the next. So what I will do is I'll just briefly explain what we mean by whatever we are going to study today. There is a concept, of course, the data is one of the main things when we talk about computers. There are two components. There's the data component, there's the program component. We are concentrating on the data component today. And some years, it didn't happen at the beginning, but many years later, somewhere in the 70s onwards, the programmers were finding it difficult to write their own file structures. So instead, there was an idea, why not we make a software which will handle the file structure, so the programmer just submits the data and retrieves it. That is how the database concept came. Of course, this was for the mainframes. Then in the early 80s, you saw a lot of databases for these PCs, like DBase 2, 3, Foxbase, Clipper, etc. And then of course, we are comfortable with this MS Access, and today we have a lot of them, this MySQL, a lot of open source, and like Microsoft SQL, a lot of paid databases also. Large ones are also available. So this is what we are concentrating on, ready-made product databases, and how do we use them as an auditor. The second component of our presentation will work on the large, actually it's not really large, we say big data, but it's basically data which can be external to the organization. It can be internal also, but it can be external. Why do we need that external data? Because there's a concept called benchmarking. And of course, years ago, benchmarking simply meant ratios. But today it means a lot more than that. So when we get there, I'll explain. So we are now talking about how do we get data out of a database using what is called a structured or a standard query language. So I'll concentrate on the query language first. I mean, if you have a question, why are we not studying the theory? Why are we going straight into the commands? The reason is, well, as an auditor, you will pick up a lot of data. Maybe it's in Tally. I mean, it's the easiest one, Tally. It could be bigger than that. It can be some ERP or some larger software. Normally, what happens is the auditor asks access to the client's production system. Sometimes it's given, sometimes they make a fuss. But if you ask for a dump of the data or an access to a dump, they can dump it on their own machine. They only need an access to it. You can run various queries. Queries are basically questions. You can interrogate the data in so many ways, and then you can come to your own conclusions. Serious conclusions, we call them insights, call them patterns. We got fancy names for them. But basic thing is, we can ask simple questions like find mismatched items. Okay, that's the simpler one. But you can also start looking at suspicious patterns, red flags which may indicate fraud. A lot of things you could do. So the bottom line is, do I have to learn SQL? So it is yes. The answer is yes. Of course, we can use a lot of CAT tools which can do the queries. For those of you who are trying to use SQL, I'll just cover this as quickly as I can. You can download a package. Actually, the package which I'm suggesting for the download is called, I think the slide is over here. Okay. The slide, okay, I think I'll go right to the end to come back to that. Okay, anyway, I'll take you right to the end. The slide we are talking about is, I think I have missed that slide, doesn't matter. I'll insert it here, there's no problem. We are going to use a software called SQLite. SQLite. So I'll just insert a slide here. So it should not take, it won't be very difficult. So you can just download whatever I'm putting here. The slide we are talking about is SQLite. Just make it all capitals. Okay, now this is the software which we'd like to use. The SQLite. It's a free software. It's open source. When I say free, it's not that free where you'll get all the bugs and viruses and so on. This is open source, so you can download this. Doesn't need any complicated installation. Nothing there. It's not even as complicated as MySQL. MySQL itself is easy, but this is even easier. So for auditors particularly who are learning, this is the best. And once you install it on your machine, laptop or desktop, you can start experimenting with large data dumps. It's useful for learning as well as very large data processing. So you can go with this SQLite, just download it from the internet. Plenty of YouTube videos, plenty of books, and a lot of stuff is available. I'm not selling the idea of SQLite. This is the easiest for us to learn. Then we'll get straight into the language, the structured query language. Now, there is a concept of what is called a relational database. Earlier, we learned a lot of databases. Today, just bring it down to two. The older ones called relational database, or rather, when I say older, the more popular one. The newer ones, of course, is a big data, unstructured data, and so on. So we leave that off for the time being. That's next we'll study that. Let's stick to this relational, starting with large ones like Sybase. Sybase is gone, but check Oracle, DB2, and so on. Or the very small ones like MS Access, or like I told you now, SQLite. Actually, SQLite can do a lot of work. Actually, it's both a easy package, but it can handle large amounts of data. That is a relational database. That's a name. I just call it a database. That should do. Now, there are some names to be understood. A table is a file. What is a file? So let's say we are putting all the records of sales or purchase or whatever. I think a common thing many auditors do is reconciling those GST forms. You dump those data somewhere, purchase data, or even something even simpler. Let's say a list of employees. That's a file. Now we'll call it a table. I just remember the names, a table. Now every record, one employee is one record. You maybe got his number, name, age, what date of birth, blood group. That's called a row. So file is a table in relational database terms. Record becomes a row, and then each of those fields in the record, like the employee number, the employee name, date of birth, that is called a column. You may also find some new names. Sometimes they call these rows as tuples, T-U-P-L-E. They're all just names. So whichever book you read or however you're following up, they all mean the same thing. That is, fields, rows, fields are the columns, rows are our records, table is the file. I mean, that's something we have to use. I mean, those are the names. I mean, that's the easy part because you just had to map one-to-one file, record, and field. The rest of it is the syntax. So the syntax part is just a diagram. I'll go to the detail. Now this SQL server is what I'm calling as the SQLite or the MySQL or MS Access or whatever we are doing. So that is the SQL server. As a generic diagram. So the SQL server is, if you are practicing, going to practice all this, whatever you're doing today, this would probably be SQLite. If you already have MS Access or something else, MySQL or MS SQL or Oracle, use it. No problem. Now, when you run your commands, they're broken into categories. So what are those categories? The DDL is the data definition language. Now, what does it mean? I mean, what are we defining? So when you're creating a new table or when you're changing the structure of a table, I mean, I have to explain what this means. When you say create a new table, I'm creating an employee table. I've got some data from the client. Maybe it's a spreadsheet also. You can import spreadsheet data also. So maybe it's a spreadsheet data and I've got this spreadsheet data. So what I've done is I'm going to create a table structure. That's a file structure. I'm going to have number, name, date of birth, something like what a blood group, hours worked, etc. Some PAN number, bank account, okay, whatever the data is. Then suddenly somebody comes and tells us, look, we need to add some more fields, or we need to remove something. I don't want the age, just retain the date of birth. Then you modify it. So modify, the command is called alter. Data, you have to watch out for one thing. Different databases do differently. If you are altering a field and removing a field, data in that field will get lost for good. So general good practice is create, of course, you would have spent some time designing it, but let us assume the best of designs also we want to change. Now at that point, you have to make sure you have a backup before you start altering the table. But don't do this without a backup. See, one of the serious problems is if you lose data, you may not get it back again. You have to go and ask the client for it. Now, if you don't want a table, then you just drop it. Drop it as good as delete. So you drop a table. Truncate is when you're changing cutting off the records or shortening the table. Mainly, you'll be using create. I don't expect the others to be used. Create will do for us. Now, data manipulation language. Okay, I created this. What do I do with the structure? I have to insert data into it. So you have a select command, which is the query. It gets you data from the table. Insert pushes data into the table. So this is like reading, this is like writing. I mean, like a flowchart. You say reading, writing. So reading is select, writing is insert. I want to modify the data, alter it. I want to update something. Then it's update. You want to erase some data, not erasing the table, just the data, nothing else. Then it's delete. If you're modifying the table, it's alter. Modifying data alone, it's delete. Then we have the data. These are the command language where you grant rights. Now, one of the main things is in a databases, with a large databases, a lot of people will have access to it. Right from people are entering data up to those who have the right to maintain, delete. They're called DBAs, database administrators. So each one gets a different role, or we say rights. Now, if you are giving someone a right, it's grant. If you're removing a write, it's revoke. May not be important for an auditor's perspective, but in an audit, if you are looking at access control, then you have to see whether these commands are actually being run. You can take it from the log file and then you can check. Then the transaction commands are, actually this is when you're running a kind of series of commands. Let's say it's a point of sale billing. You're writing data to the stores file and also the sales file. And after we wrote it to the stores file, the transaction crashed. Some reason or the other, the network connection broke or something happened. Now, if you want to, you can't leave half a transaction updated. So then what you do is you roll back, which means just go back to that point where you were when you just started this transaction but couldn't complete it. If you have completed the transaction, then we commit, which means it's finalized or freeze it. So what it means is every time you're doing something, any of these commands, except the grant and revoke, the first two, DDL and DML, it's not actually modifying the database. It's holding it in a temporary file. And then based on whether you wanted it to cancel, that's the rollback, or you wanted it to freeze it and close it, that's commit. So that's the advantage you have with the database. I'm looking more from the auditors as an audit tool. But if you're auditing a database, then this is very important to make sure that I just gave an example of 2 files being updated. You can have any number of files being updated. So now let's get into the language commands. I'll do this as straightforward as I can. Anyway, the presentation will also be shared. You can download SQLite and give it a serious try. Okay, the overview of the SQL is just what I told you now. Now let's get into the language part. How do we create tables? How do we insert, etc.? How do you manipulate and correct? How do we insert data, delete it? How do we get back the data? In fact, this is the most important part. When you are auditing using SQL, we can always use CAT tools. That's always available. But as you know, CAT tools need licenses. They're pretty expensive. And there's a lot of work which CAT tools can do. But today what has happened is the CAT tool manufacturers are not really updating it because the audit requirements have become huge. Technology also has become huge. So they just leave it. People are writing their own whatever R language, Python, scripts. Big firms write it. Small firms, difficult. This is the easiest for a small and medium firm. All you need to know is just spend some time. I think in less than a month, you can start writing scripts. I'll go through all these commands. This is just an introduction slide. Now we know it can manipulate data, change it, alter it, edit it, whatever. It is not a language. Actually, they call it a language. It's called 4GL, fourth generation language. But technically, it's not like a serious program like C or Java or something like that. So it's not difficult to learn. It's very easy and it's 100% portable across relational databases. Now these commands, okay, this word interpreted means it will be run line by line. So do you have to write a big program? Not necessary. You can type these commands at the command prompt itself. It will be interpreted line by line. There's no problem there. So sometimes, we should call them scripts. Whether you write ACL scripts or IDEA scripts or SQL scripts, they're all called small, tiny programs. You can write these scripts and run them, or you can type them line by line. Now, this is another advantage is you can run it interactively, which means as I type something greater than 1000. Then I realize 1000 has to be included because greater than 1000 will exclude 1000. So I can type again, go back and type greater than equal 1000, it'll work. So that means you're doing it on the fly. Just like you use spreadsheets and formulae, you can use SQL. Last point, of course, may not use it as an auditor. You can embed it within languages like COBOL, C, or wherever you want, you can embed it. This may be more useful if you have large audit programs, software written, but now they are audit firms write this software for governance also, GRCs. You can embed it, but actually you can drop the last point because right now What I'm teaching is not programming. It's more like commands which you can learn fast. Of course, this we said the DDL definition language, DML manipulation, DCL data control, and of course we put one more TCL transaction controls, transaction command language. Now we'll start with the first of these, the data manipulation, where we talk about we are inserting data, we want to update content, we want to delete something, we want to query select, of course. Now these are the syntax. I'll spend time with this. Actually, I'm trying to teach you all SQL because this is one of the things which is very old. I guess SQL is pretty old, but we have not brought it into the audit tools and techniques. It's taught in the whatever those hours, computer hours, which are covered. But we'd like to just quickly learn this as fast as possible. Now the syntax is insert into. What is in caps is fixed. I mean, you can't change it. The name of the table. So when you said create a table, earlier command create, you have to give a table a name. Table means file. Let's say employee file. So we'll say insert into employee file. What are you inserting? You're inserting some data and you're giving the field names. Remember, column was field, row was record or tuple. So you're giving the list of fields, then the keyword values, then you give the value list. Okay, in the column list, if we said number and name, in the value list, I'll give 5, ABC. 5 will go to the number and ABC will get stored in the name. So here we have a small example. Insert into, though this is in capital, it's not mandatory. This is your table name. Course is a table name. You are inserting the fields course code and course name and whatever the credit hours. So the values are MIS 499 will go into course code. Advanced Oracle will go into the course name. 4 will go into the credit hours. So if I select later, I won't get all these names, course code, etc. I won't get that. I'll only get this data, MIS 499, Advanced Oracle, and 4. So each insert will put one row or push one row into your table. If the table already exists, it will keep adding it to the end of the last end of the table, just after the last record. So this is the first command. Now the next question you have is, should I insert the, suppose there are 1 lakh record journal entries. Do I have to insert them one by one? No. You will be importing them straight into the database from a SQL, from a spreadsheet or some dump CSV, comma delimited file, which comma separated file, which is given by the client. Then you won't be inserting one by one. You just import it and then we'll start using it. When do you insert? Only when you're probably learning. Right now you're learning. But later on, only if you want to insert a record or a few records in a loop, specific data. You may be inserting control records, you may be inserting some break which you want to know, like every month's data ends, you want to add some marker. It all depends, control totals, batch totals, whatever. Now, when we said insert into course, etc., and we did not give a list of field names, and let us assume the file itself had this in the right order. It had the course name, the course code, and the hours in the right order. You don't have to mention it. See, here we have mentioned, but you don't have to mention it. You can just put this as it is. So you can first field, first data will go to your first field, second data go to second field, third piece of data will go to your third field. Now, if you insert a column in every column, same order as the table, there's no problem. But if you have got the course name, course code, and credit hours, but your data order is mixed. Now you wanted in the table, the database, you wanted the data to be in a particular order. Like say, okay, I want name first, course code next, credit hours. Maybe that's the structure. Because you may be concatenating a lot of tables later, making it into bigger tables and so on. But the data which the client gave you, he gave you the thing in a slightly different name. He gave you the course name, course code, and something else, some number. Then specify the field names. Otherwise, if I don't specify, this advanced Oracle will land up in your first field, which is your number, course code. The MIS 49 or 499 will end up in the second field, which happens to be a course name default. 4 will, of course, go to the right field. So if you see the field order, we have course code, course name, and credit hours. Here we gave it in the right order. So whether you specified the field names or you did not specify the field names, make no difference. But in the second example, if I got my order mixed up, I have to specify the field names correctly. Otherwise, it won't work. It will work, but it will all go to the wrong fields. Now, there is a concept called null data. Now, null data means it's actually we say nothing, but null is actually ASCII code 0. So it is a binary processable field. It's not something which we don't understand. It is a binary field. But the point is, you want to leave it empty. You don't even want a space. You don't want anything. Now, if I put 499 and 4, and I gave only 2 field names, I didn't give the course here. What will happen is the first data will go to the first field, second data goes to credit hours. In between, see, we have 3 fields here. We have course code, name, and hours. You don't specify data for course name, then that course name will become empty. Null means empty. And one of the things we have to learn in computers is a space is not empty. So space or 0 is not empty. Empty really means ASCII code 0. You don't get, I mean, you can easily identify those fields or records. Now, if you probably wanted to skip this, then, I mean, we didn't want to put these names, so we just skipped the field names, column names. We have the first, which will go to the first field. This open and close single quotes. Okay, the single quote, double quotes confusion. You can put anything you want. You can put double quotes or single quotes, but just remember that if you want to put a single quote, like say today's menu and TODAY apostrophe S, if I have to enclose the today's as a string, I have to open and close double quotes. If I open and close single quotes, it'll all get mixed up with the apostrophe. So you'll have to open and close double quotes. But in case you just want a null, just open the single quote, nothing, no space, nothing, close the double quote. So we'll get MIS 49 first field, null in the second field, 4 in the third field. What's the advantage? Here we specified the fields, so we didn't specify the null. But here we didn't specify the fields, but we had to specify the null. If you're having any doubts, of course, you could try these out. I'm sure this will be clear. And the null is also a keyword. That means if you type NULL, SQL will understand what you're saying. Okay, you want ASCII 0, you will get it. So that is also possible. So this first time we got null because we never even mentioned the field name. Second time we got null because in the data we put a open and close quote. And the third time we got null because we actually wrote NULL. We put it there. Then we get into this insert. Insert is your dumping records into it. Now insert into section values, okay, some table. We got 1, 2, 3, 4 is one field, MIS 333 is another field, 10, 11, 12 is another field, MW is another field, and so on. So we have got all these fields. Now, when we do this, when you're inserting some values, now for instance, this syntax here, which says insert into something 1, 2, 3, 4, that's it. It'll automatically go to the first field. MIS 333 second field, etc., and so on. Okay. Now, when we come to this, the line, the integrity part of it, see the course code, which we are mentioning. So this is one value, this is another value, this is another value, etc. So the integrity constraint, when we say parent key not found, actually I should have mentioned that here. See, every record has to be identified uniquely. Each record has to be identified uniquely. So maybe you're using a product code or employee code or something, some way of identifying. Now, the key field is very important. So the problem here is if you don't have the parent key found, now for instance, I put a course code, I got a field called core, a file called table called course, but I don't have a proper matching for the course code in the course file and the course code in the section file, there'll be a mismatch, which means I'm not exactly finding the information. So we have to be a little careful that all our spellings, the upper lower case, whatever, inverted commas, double quotation, single quotation, and they're all up to date. I mean, they're all correct. Now, if you said insert into course, okay, again a number and some new and 4, insert into course values. Okay, we've got some values here, same as this one. Now you get an error at line 1 where it says this code is violated. So we have to check what exactly violated the code. So in all these cases, what we're saying is fields and data have to match 1-to-1. That's for the field name. If you don't have the field name, it's fine, but it has to correspond 1-to-1 with the whatever the field design we have done or the record layout we are having. So we need to follow the order of data very correctly. Generally what happens is when data is given to you or when looking at data from somewhere else, the order will be completely different. So that's the only problem we'll have. So we have to be a little careful not to get confused. Now removing data, same thing. If you say remove, delete the whole course, the whole thing is gone. You delete course for a condition where course code equal to MIS 20 deletes all the records with the keyword MIS 220. Now your next one is delete the course file or course table. Where the hours equal 4. Okay, what it does is, or you can say hours equal, less than 4, greater than 4, whatever, it'll delete whatever you specified. So you can give conditions for the delete also. Sometimes you say remove the older records. Sometimes we say remove the records which have already been processed. There are various ways of doing it. So wherever you find that you got thing where hours have to be specified, or money or rupees or whatever quantities you're specifying, reasonable quantities, just make sure that we got this delete completely under control. Don't delete the whole table. Suppose I delete course. I don't have all this. Simply delete course means my entire table is going to go empty. All the records will be erased off. Not even a single one will survive. I mean, all the records meeting the criteria. Now, this is where we talk about deletion and integrity constraints. Now, what is integrity constraints? Now, we are trying to update data, modify it, etc. One person, he said, I'll start as a watchman, he got an account. Another chap said, I'm a driver, he gets another account. Another chap is a cook, whatever, catering, some tea shop, he gets another account. Now, when you're trying to merge them or remove them or do something, then you just specify the key field and the record is gone. It just disappears. Now, here why you got an error is when you try to delete a master record, there is another record which is tagged to it. So that's I mean, it's basically we say we won't. I mean, it's a tag. So what happens is like if I carry out some, let's say it's a student paying his fees, but I don't have a record of the student in my student's file, then we have a mismatch. It's an integrity constraint. We are trying to pay fees for the student who's not a part of the system, but maybe you would like to block it and then use it. I mean, somebody is doing mischief, a hacker. would like to block that address and use it for something unsupervised or whatever. So you got to be careful. Don't worry too much in the child relationship and all those things. But what we should depend on is from time to time keep checking whatever you got, so it makes sense to the the client or family or whatever it is. The next is updating data. Now you're not inserting data, but you're changing data which is already there. You bring it up to date. So that's the updation of the data. So the updation of the data, what happens is the field value, whichever field is specified. For instance, you said update course, set hours equal 5. Hours is your field. It'll change its value to 5. Only problem is all the rows have got affected. It's a machine, so doesn't make much sense. So maybe you've seen something you want to specify, but then the change is applied to all the records, which is wrong. It should not happen. So this syntax is okay, but logic wise wrong. Unless the intention was that we want to erase the whole thing or change all the records to 5 or whatever. But instead what you do is, two ways of doing it. Update course set hours, whatever 5, where course code equal to something, etc. Changes one row at a time. Update course set hours equal 3, where course, okay, the code which is generated is what people are going to see. So you want to bring that also into account, you can do that also. Before that. Okay, before that, if you have to put in something like a group of rows like MIS %, this can represent MIS 220, it can MIS 190, it can enter anything, you will get it. It's like MIS, say, just MIS is just a field name. The percent here is substituting a group of rows, which means the number of records, or in simple terms, the number of observations. So that's where it all works. Now, if you are changing the value, okay, this foreign key, primary key, don't get too worried. In the employee file, primary key can be employee number. But in the PF file, the PF number will be the primary key. Primary key uniquely identifies a record, and the employee number in the PF file will become the secondary key or foreign key. Those are the names which are used. So you can change the foreign key as long as the new value complies with the referential integrity constraints. Now, let's say we are referring to a town name, and that town name is again referring to a branch code. Now we want to do some changes. I go on middle of the town name table and do something, I erased it or something I did. Then what happens is the link between A to B, B to C, if I remove B, the A to C link is also gone. So most of the databases, the big ones, will not allow such a delete to happen. It will prevent you. But when it prevents you, if you force it, of course, it will go off. But then your records will get orphaned or zombie records. They don't belong to any. The second part will be missing. So on the integrity part, let's say we update the course, set course code to something where course code equal to 220. Now, wherever this record with the course code 220 occurs, we want to replace it with code 221. But then we need to know where the update is going. Now we cannot do impossible things, so it has to be reasonable, and we need to know how many records it will affect. Suppose the filter is wrongly set or the query is wrongly set, everything will go wrong. Now this is the rollback and the commit part of it, where we know that, okay, we're doing something, so we can either close the transaction and freeze it, or no part of the transaction did not execute, like a payment gateway failure or something, and we don't want to close that particular unit. I mean, you just want to keep it open. So here, when you look at this rollback and commit, this is changes to the data temporary, does not apply to changes in database structure. Before leaving, okay, SQL Plus is put here, but you can use SQL Lite. You can reverse them. So okay, all these insert, update, and delete are the same problem. If you're trying to do too many things at the same time, and then you're not able to sit at the same location every day authorizing transactions or whatever, then better have a separate team which handles it. Now the syntax for rollback is just rollback. I mean, that's the syntax. It reverses all changes to the data the session is made. Commit is the opposite of rollback. It'll make sure that your data is committed, which means like it's already fitted in. So once it's done, then of course commit is going to store the data, and rollback will drop the data. It won't use it. So again, we have another syntax. Now we had insert all these examples earlier. Now we're trying to select. Select is from this column name. We need to pick up from the table name where the condition or not the condition. So where is a Boolean variable? So say where true, where false, where 1, where 1, 0, and so on. Now this will retrieve the specific fold values for the specified conditions. And every select statement will return all the records meeting the criteria, all the records. It will not be just one or two. It will meet all the records, or it will return all the records meeting the criteria. Now let's look at the semantics of an SQL query, which I told you very easily it's greater than, less than, equal, not equal, and so on. Now semantics basically is a study of how this is formed, the language structure is formed. Okay, what it says is you can compute the cross product of the relation list. Relation list is I have 100 vouchers with me, they all belong to 10 accounts only. So we call it posting. So we take this and whatever the volume of vouchers, don't waste on the road. And then you'll be able to get this relationship. May have to hold on, I'll come to this. Then discard any records, tuples here are records. If they fail the qualification, what qualification? It could be anything. It's probably fulfilling a head role, or maybe it's something else. I'm doing something else. Now, if they fail to meet your criteria, you drop them. Then, of course, a target list, they're not in a target list, you lose them. And this one here is, we're saying that, look, if you're going to do all this running through the entire population one after the other, then it could be inefficient, or it could probably lead to mistakes. So what we're saying is you can pull out the data, but make sure all the commands are running clean of whatever this any data which is going to character. So we just want to be clean of that. Don't use it for the processing. We'll come to an example also. Now, where I told you is you give the condition. The where is not executable. Where a condition asterisk from course, where course code like MS something. Now the percent in any place you see will substitute, please say, well, they will substitute for the string. But if you said, this will be MIS1, MIS10, MIS499, MIS330. So the percent is now substituting for a group of characters. This is very specific. From the course, you will get only two, not two, but records meeting the criteria. We'll get only the hours 3, 4, and 5. There are only two records, only 4 and 5 tandem. Now you want all of them also it will bring, of course, this is the only lot they have there. See, it's not, one is you picked up all records meeting a condition or a criteria or shape. Now this is just picking up those which specific values. Now you can also go for a regular traditional logical thing, like select from customer, which is the table, where balance and the credit limit are compared. So you can where the balance is less than the credit limit. Okay. Now the where command is the condition. Now we have studied this as the condition. So if you want to pick up journal entries only at the beginning of the month, condition will be date. You want to pick up something which is done by the stores department, it was issue note and receipt note dates. So once you get the dump from the client, you would like to extract in different ways. So you're extracting asterisk means all records, all of them, no particular field, all fields, from a table called customer, and we got some 3 states, which means other states, if at all they exist, they will not get picked up. Whereas the next one we have gone for a numeric value. This was state in, it's more like a set, TN, etc., whatever, KL. Here it's more of an arithmetic check, where 2 values are subtracted and then it knows, okay, if it is positive, it's less. If it's negative or 0, it's greater or more. So based on that, it will pick up the value. That is credit limit minus balance should always be less than 1,000. If it's not, show it out to the person who has to deal with it. Then you have this usual Boolean operators and or and not. You select all the records from a customer, from the customer table, where the balance is more than greater than equal 500 and less than equal 1,000. You notice you repeated the same words twice, but actually it's not going to overlap, because if you say 7, so let's say 300. 300 is not greater than this one, so it will go to the next one. 300, it will again compare less than 1,000. Yes, but then and means both of them must be true. There should be no false. And is all the criteria given are going to be true. But on the other hand, if you didn't want everything to be true to come, then we say it's opposite of true is false. Okay, so where is the false coming? Select some asterisk, that means all the records from a customer where the state ID is TN or credit limit greater than some whatever, some value. Now 2 comparisons are happening, and then of course, actually we're not getting into the writing of scripts, but we just want to know each line what it does. The next one is select from customer where it's a negative thing, not state equal TN. So all the states will come except any state starting with TN. That will not come. So because I explicitly stated that, so it'll forget that part and continue. Okay, this and or and not, let's not go too deep into it, but I'll try to explain. See, we are picking up all fields from a state called TN where the credit limit is equal to 1,000 and the balance is less than 5, which means now we've got 3 conditions. There is an or and an and. State equal TN or credit limit equal 1,000 and balance less than 500. So one thing is sure, the customer has to be from TN. So if we went through this data here, TN is in the first record, third record, and the 4th record. But will all of them get picked up? No, we don't know. Let's see the rest of the conditions. Our credit limit is 1,000. So we have to go back and see the credit limit. There are some people at 1,000 and TN. 1,000. So this is like, should we get into this? It's also not considered. But okay, somehow we are able to get this thing done. Then when the person comes in with the camera and he looks at the data, your transactions from TN will only get, this is 500, but this is not less than 5, I'm sorry, this is 1000, but not less than 500. This will fail straight away, it's not equal to 1000. This D, the row with that cust value D for Delhi, it has TN, then it has 1000 equal to 1000, then it has balance greater than 500. So that's the only record which will get picked as a 200. That's the only record which will get picked up. I know this may not be very clear in the first run itself, but it's easy. State should be DN, credit limit should be exactly 1000, balance should be less than 500. Though there are 3 TN records, only one will meet the criteria. Now, if you want to change column names when you pick them up, I don't suggest you do it unless you're doing this on an arithmetic field. You're generating a new field. I don't want the formula, I want an English name for it, like discount or value or something, then go ahead and do this. You select the employee ID, last name, first name, etc. and DOB from employee. Now, employee itself is what we are processing. You just go pick up the desktop procedures from this file. So when you select these 3, whatever up to birthday, you are selecting them as DOB. So the birth date will not be a field in your system. It will be DOB will be the date in the system. Similarly, if you again change the E, for instance, have some slide where we change it. Okay, then we can straight away say, get me from the file E instead of employee. Now, naming convention should be reasonable, easy to remember, and should not be easily exploitable. Okay, that's what we say. So when you fix your passwords, we can now, every week they do that. If you're changing, then you have to be very careful. What I would do is I'd skip this slide, don't worry, but please try it out. You're just changing the name. So birth date will appear as DOB, nothing more than. Now these are all the operators. So distinct is a word by itself, it's an operator. Arithmetic will be plus, addition, minus, subtraction, multiplication, then the division. Comparison is usually equal, not equal, greater than, etc. Substring comparisons, we got a percent where I said you can substitute one or more characters for it. You can use it's called a wildcard reference. You can use this between and or. We'll see now. We'll see the usage. Then if you are using an index or if you're going to run it fast or parsing, parse those records, then we say order by clause, then union, except, intersect, and then in. In is like inclusive. We left it out kind of. So the union, except, and intersect is when you, I'll tell you the joins. I may have how to join the inner joins, etc. I'll come to that. Order by is to rearrange the data. So that's the order by. Now I'll do one thing, this join and subquery. I'll first take you to the diagram. Now okay, as an auditor, you'll have multiple tables. I mean, I gave example of employee, but employee is not one table. You'll have payroll, you'll have TDS, you'll have some transfer file, deputation file. Okay, I mean, depends how big the company is. Now you asked a dump and you got the dump. Now you populated all the different tables. Then how do you process? What do you want? So this is actually from your De Morgan's laws. The pictures will make it easier. Then we'll go to the commands. Now, if we say asterisk, is all the records. If we say select something from, and then the key you are given, it should pick up. Keys are equal, it will pick it up. But we added some extra words. A left join, that is A left join B. This is A is the table name here, B is the table name here. That left join B means, and then A dot key is equal to B dot key. It will pick up all the records in A, even if they are unique or overlapped. It doesn't care. It picks up all the records in A, but it will skip all the unique records in B. Overlap it will pick up, unique it will reject. So when you're doing a left join, the left tables, all the records will come, of course, subject to the conditions you're giving. All the records will come, but nothing will be selected. Opposite of this is the right join. I'm just going straight here, right join. Now this is the opposite, which means if you A is your first table, B is your second table, A right join B, all the records from B will come, A will not come. Now let's say this is the master and B is the transactions. Now we want to see the completeness of the master. So a master may have a transaction, may not have a transaction. We are okay with it. I want to pick up all the master records. It picks it up, regardless of whether B is a transaction file, whether a transaction took place or not. Now this is the reverse. I want all the transactions, including ones which are supposed to be wrong. They don't have a master entry. Some issues are there. Now this overlapped area has master entries. A is the master, B is the transaction. Overlapped area has master entries, but the rest of this big portion of B has no master entries. I still want them. So I want to see all transaction keys, and maybe we'll filter it later. If you see the intersection here, we can take where the keys are common and reject the rest. We'll have to plan out what we are doing. What is the objective of that analysis? What's the audit finding we want? Masters with no transactions or transactions with no master. This usual stuff which the auditors will normally do. We have to make sure what is the objective, what are we trying to do. Based on that, we can pick it up. It's pretty simple. It's straightforward. Straightforward part is the syntax. The complicated part is which syntax to use in a particular scenario, audit objective. The inner join is actually the intersection, which means both must be there. If I was thinking of this as a master, this is the transaction. I have master records, I have transaction records, keys are matched. Only those I will pick up. I may have masters with no transactions, I'm not interested. I may have transactions with no master, I'm not interested also. Now the next one is when you do the left join. See, if this A left join B, but this is you're selecting from A, left join B, and also want to make sure where the B dot key is null. Now you want to pick up all the records from A minus anything which is in B, including the overlap. Now this is again, okay, in a simple language, these can be masters without transactions. Actually, when you do payroll, if you're finding a master without transaction for the whole year, your doubt is whether it's, why did they create it in the first place? It may not be a ghost employee because ghost employees get salary. But these could be dummy masters or dummy records sitting there, waiting to be activated by some fraudulent person sometime later. Okay, this is, I'm just expanding on that, but this is basically the syntax. Same thing here, transactions only, and we are not bothered whether it has a master or not. If it has a master, we are ignoring it. Only transactions without master we are picking up. Now here, this is the, when you have full outer, it's called the union. All the records will turn up. This may not be for a audit objective. This may be more to concatenate tables. Okay, that's more the reason. And then you have a full outer join, which means any common area is left out, so it may not be master and transaction. This may be areas where the same ID or employee ID is appearing in employee codes and the vendor codes. There's a standard audit test. If they appear in both, it's a fraud. It's not a fraud. It's a red flag. You have to investigate further. I want to pick up where it's not overlapping, or if I use an inner, I want to pick up where it is overlapping. My example changes if A is the employee and B is the vendor masters. If there's a common whatever address or bank code or something, okay, it's a red flag. Here we're trying to leave the red flags out and take the others. Now, if you go back to the syntax, this is the syntax called join, and then subqueries is where one select command is nested inside the second select command. So here comes the join syntax. So this was syntax is also here only. Select asterisk from and then A left order. In fact, this is the easiest one. Select asterisk from A inner join B, and of course, since I'm the key, maybe employee code or whatever, what are we calling it? Making it very clear. From table A, take the key and match it to the table B key. If they match, yes, I want this. Here also same thing. We are giving the where A is empty or B is empty. Null means the key field has no value. If they are equal, obviously they have value. Null and null matching may not make sense. So values are matched. Nulls are generally used for exclusion. The empty field, I mean, something is wrong with that field. Actually, it happens when many companies where they create a lot of masters, and they are also experimenting, testing, debugging, or sometimes they have something called data migration, where old system, the transfer system, I mean the data into the new system, made a huge blunder. They forgot the master keys for some of them. In fact, bigger the company, the more blunders they make, because usually the finance people feel their data is the most valuable. The software guys have no idea what finance is asking them. So somewhere they'll have some youngsters writing some code. Code will be like this, something like this. And then they'll bring it to a spreadsheet from the old table, and then they'll import that spreadsheet into the new table. May make sense. Invariably, it may not make sense, because remember, there's a syntax written by the programmer and or the coder or the SQL person, and a finance person who's giving them some instructions in English, like I told you, like find common bank account numbers between employees and vendors, and that guy is writing something in SQL, so they'll make a mess. So wherever, that's why if the auditor can learn both, of course everything else SQL is only one missing. So if you learn it, spreadsheet also you already know, it'll make a lot of sense. And not just for migration audits, basically it's for any query. So if you look at the syntax here, we are selecting from the entire syntax. Okay, what we're saying is, the C here is a table name, this is the field name. If your field name recurs across tables, use the table name full stop, then the field name. So I'm very clear. I'm taking the customer ID from table C. This whatever this comp name is common, so I didn't put any field name. I mean any table name, then country, order ID. Now I'm taking from customer is my table as C. That means this is actually customer table cust ID. Order as O. So wherever I see O, it's an order table. Now I'm selecting customer ID, whatever the complete name or whatever country, etc., where the ID in the customer file and ID in the order file are the same. What are we talking about? Customer file is a master file. Order file is a line item file. One customer can place many orders. So in the order table, we have got say 100 records for each, not each, but maybe one customer has no records, another customer has got 50 records, another customer has 100 records, no problem. As long as the customer numbers from the order and the customer master match, we are picking out the ID, name, etc., country, order. Only thing is, why did we abbreviate? Can I write this as customer.cust, customer.cust ID, order.order ID? Yes, you can. There is no problem. Right. Okay, this was to shorten it, but if you feel comfortable just using the full names, use it. I mean, there's no compulsion to use an alias name. It's called alias name. I think we put it in the syntax. Okay, we didn't write it, but okay. This is called alias name. Okay. What we're saying is, C is the alias for customer and O is the alias name for order. It doesn't matter. If you don't use alias names, it doesn't matter. Now we are saying the customer IDs must match and the country, when you say and, both conditions must be true and the country must be USA. If this matches, we get this record. Now you may be working with data which deals with dates from different files. Usually this JE testing, as they call it, journal entry testing. Normally we'll use some DI tool like Excel or Power BI, but if you want to run SQL, it also makes sense. The output from the SQL, you can put it into your visualization software and draw your graphs or tables, or I mean, not tables, but whatever kind of picture you want to draw. So what we are trying to say is that these joins, nested selects, whatever, will help us to get more refined searches from the data, which is very difficult if we have to use an Excel sheet only, or even a CAD tool. Up to a point is okay, but beyond that, it gets a little confusing because you're driving it through a menu. This is you're driving it through syntax. So it's a lot more, I mean, as you learn. So if you don't learn, menus are easier. It's like I said, you find smaller installations, they usually have a menu for running those T codes. But if you go to bigger installation, they'll type the T code. Obviously, users get trained better. So we'll go with the same argument. When we are beginning whatever early stages, let's go with the menus, friendly software. As we learn, let's move on to this SQL. So I will kind of come to the end of this section. If we have any questions at this point, I will take those questions. Do we have any questions at this point?
Yes, sir. 1 minute.
Yeah.
Let me just check. So, is my screen visible, sir?
Yes. Okay, the question is, which file do I have to download in SQLite? Just put SQLite in the Google search. You will get the link to download it. Download the entire package. It'll install. You'll get that install file. It's a single install. It's a straightforward install. So there'll be no difficulty at all. You can do it. Both of these are SQLite. Will we get an opportunity to see how it's done? No problem. See, all the syntax I gave you in that various slides, you can just type it as it is. No problem at all. SQLite has got a lot of YouTube and actually books. And the reason why they use it is actually it's not for auditors. I mean, I'm trying to make auditors use it. It is meant more for these, when you're analyzing data for analytics, and the AICPA, which is the American Institute of Certified Public Accountants, they have a guideline which is called ADA, that is Audit Data Analytics. They have given some cases and all that, but they didn't recommend SQLite. They just gave the cases. So if you're either studying or you're an auditor, it makes a lot of sense to, need an SQL. See, as you get better and better, you can use large ones like MySQL or PostGRE and so on. But problem is technology changes, products change. So I suggest we go with SQLite, because once you learn your SQL, okay, you still use SQLite, it's very powerful, but you may switch over to something bigger also. So don't worry about the example. Actually, I don't have that SQLite on my machine. I'm sitting at home. But that's okay, fine. You can get a lot of these. It's like normal SQL. So don't worry, there's nothing different. Or maybe I can just try a few Google images for that, and I can try that. Okay, so I will have to share my screen. Before that, there's another question. I'll finish that off. Can SQLite work with any banking software? Yes. Only thing is, ask for a dump of the data. See, what normally happens is when you get access to their system, the DBA or whoever is giving the permission, they'll say only view rights, this right, that right, and they will. Okay, I'm not saying a bank is bad, but what I'm saying is they may not give you some data which you really require. I'm particularly talking about problems like NPA data or even ADF. Sometimes I find they do that. See, I'm not blaming the banks. See, they are also lost with all these circulars and requirements. And generally, the statutory auditor is not also fully up to date with all the requirements. So we go by guidelines. Institute book is very good, but you can go that step further, and they won't give you a dump on your machine. The dump will be in their machine. You'll get access to the dump. That is the main thing. They won't give it to you. That's okay. Not even a bank. Even companies make this fuss. So you can take the dump on their machine, ask them to dump it on their machine, the IT chaps. You can plug into that dump from your machine, or if the bank has given you a desktop or something, no problem. Access that, and then yes, you can run all your whatever bank things you need to run. Just make sure the audit objectives are clearly identified. It may be interest calculation, recomputation, reperformance. It may be whatever it may be, NPM mapping, whatever charges, loan origination, it doesn't matter. So you can pull lots of data out and check. Okay, the only problem sometimes is you check too much and you find too many problems. So that you have to decide. The next is SQL query can be used for all types of, yes. SQL is standard. What I would suggest is you start with SQLite. It'll be enough. But sometimes what we do is, particularly if you're dealing with web-based systems, e-commerce, see what they do is they have staging databases or not temporary, kind of mirror kind of stuff, a free database. So again, open source called MySQL, but actually it's no longer open source, it's owned, but that doesn't matter, still no cost. You can use this knowledge of SQL directly into Oracle, MySQL, DB2, PostGRE, any database you can use. No problem with that. Next is yes, ERP also, they must have a database, a product ERP. They'll definitely have a database. Only thing is Tally will not allow you direct access except the Tally 9, where they get that object, connectivity object. You take a dump it into Excel and import it into your SQLite or MySQL. Why I'm talking about Tally is because a lot of companies, large ones, are still stuck with Tally. A new rule from April 22 is 2022 is they have to maintain an audit trail, and audit trails need auditor's examination, whether the reversed it, the history is right or whatever. And if that is a company, not a partnership, a company, only this rule applies, the audit trail. And then you have to give a lot of your notes, whatever the balance sheet, whatever it will contain a lot of statements. So yes, any ERP, including Tally, is fine. Is SQL English-based syntax, Visual Basic? Yes. What I would suggest is Google has got a lot of forums, but you can download the tutorial. Books are available, or you can see YouTube videos. Plenty of support is available for SQL. It's very old. Actually, SQL was there, remember, right from mid 70s. So, of course, a very basic at that time. It's called ANSI ISO SQL, and then of course it changed, and it is now standard. And one more thing is, if you're using Power BI and using mQuery or DAX, it's also SQL only. TSQL is also SQL. They call it transaction SQL. See, what these manufacturers do is, so one basic is a language. Microsoft alone put on Visual in front of it because it's got an ID. So you end up with Visual C++, Visual Java. They just gimmicks. I mean, you can stick with basic Java, whatever. Similarly, stick to SQL. Actually, the standard is ANSI ISO SQL. So there's no difficulty. Next question we have is SQL download page contains many download. Okay, the download link. It's a small thing you have to do. Just check with your control panel which is your version of Windows. You got 32-bit, you got 64-bit. download the correct version for your Windows. If you run system screen, not the system. Okay, you can put system in the command window. It'll open up that control panel, the screen. Just see whether you have a 32-bit or a 64-bit Windows. If you are in Windows 10 and all, most probably you're 64-bit because 32-bit is very hard to find now. But you can download the correct version. Yes, SQL will work with any, not with the ERP, but with any data dump. QuickBooks also you can ask for the dump. Actually, dump is downloadable. In fact, in QuickBooks, the auditor can download the dump directly. If he's got the right login, you can download the dump directly and use the SQL. Actually, there's one problem with QuickBooks. It's been struggling for some time with this. According to company law, this is again companies only, not the partnerships and sole proprietors. With companies, your servers are supposed to, at least a mirror should be in India. Can also, apart from the audit, if you are a statutory auditor and it's a company, take a letter from the QuickBooks supplier, I mean the agent or vendor or whatever, that a copy is being maintained in India. So that's one thing you have to do. Otherwise, you have to use trace route to trace the server. But otherwise, yes, any ERP will have a database you can download and make process it to SQL. Whether we can search for the variable to find error, yes, you can, but you'll have to find the correct error code and you have to give it. Okay, actually, if you are talking about the ITR is income tax returns, if it's huge, your TDS will come to you in a JSON file. You can download it and then import it into this and run it. That is also possible. Okay, basically what the only technical questions were, where do I find it? How do I download? You'll find it on a web page, a lot of options. Just download the one which matches your CPU and operating system. That's on the tech side. But other side, is it useful? Any ERP will have a database. You need to download from the database and use it. The other side is if you've got large Excel files also. Some companies keep this costing data in Excel. I don't know for what reason, but they do it. You can import an entire Excel data into your database, whatever database, MySQL or whatever SQLite or something, and then process it. Don't tell the client not to use it. What I'm saying is you can pull it out and use it any way you want. And if the data is now in your dump is, if it's allowed, of course, it's in your database. If they have modified the Excel sheet, you can compare tables and figure out what they did. In Excel, it's very difficult to find out. So anyway, I'm not talking about fraud, but I'm just talking about difficulties the auditor faces when clients have pushed Excel and the simpler tools to the maximum. The auditor finds it very difficult to vouch for the authenticity. So, okay, so if we have no more questions, we can take a 10-minute break. Right now it's 6:20. We'll restart at 6:30.
Okay, sir. We'll start by 6:30, sir. I'll
Yeah,
put a
sir.
break screen and
Yeah.
we'll start by 6:30, sir. Thank you.
Can we resume our class?
So
Can we?
screen share.
Yeah, we'll resume. I'll just share the screen.
Now I'm seeing the tutorial point page.
Yeah, that's what I'll just open this page. So to answer some of the questions,
Okay.
see this SQLite installation. If you go to tutorial point, you got all the steps out here. I know it's a little confusing, but it's okay because somewhere we have to learn to do things other than just those standard exe files from these, the Windows installations. You don't have to go into Mac and all that. Only here. If I change the window, you see the SQL download page. I come to the page where you have the Windows download. You have the pre-compiled binaries for Windows. You can see the zip files here. Just check your computer whether it's 32-bit or 64-bit, but generally all your new laptops and desktops will be 64-bit generally. But if somebody's got a Windows 7, okay, no problem, it still work. Then just download the right version for it, because you have this home, you have this pro. You can find it on your, you just go to the command window, type the name of your, and just type system. One screen will open up in the control panel, you can see it. So you got your, there are only three of them here, three of them here, Windows 1 and 2. Bundled one, the line commands, okay, if you want, you take it, otherwise you can leave it. Just any one of these only you have to install. And once you have done that, or before doing it, you can go into either this page, the SQL Lite installation page, or you can also look at a lot of YouTube tutorials. Very simple. I mean, actually, the installation is not the difficult part. You have to practice these commands. That's the part which you have to do. So now, if we go back to our presentation, I change the screen now. So, okay, as the screen changed now, fundamentals of databases. I'm just asking the question, as the screen changed, well, has the screen changed?
Yes, sir. I'm seeing the fundamentals database, big data.
Fine. Okay, now we go ahead with the second part of our session. The first part, we saw something on SQL, though we could have studied it as theory, but that may not have helped us much because we already know something about SQL. It's not really a brand new thing. So I thought the commands may be useful to people using it, trying to get into this part where we are automating our audits, at least to a small extent. Now, the second part is completely different. So we are talking, this would be more of theory and more of concepts, but then the point is, few of you, maybe if you're going, actually, if you really push yourself, work with open source, you can try out whatever I'm explaining. But maybe some of us may, there's a hesitation. Generally, the audit complaint is it gets too technical. There's nothing technical. It's straightforward. Don't bother about the internals. That's not important. What is important is, can we use it for our audit? I mean, that's all we are interested in. So to run quickly through big data, the story of big data goes like this. Wherever something goes wrong, people collect data. When information, basically it's data. And then they start processing it. Now, when you process it, we have statistics, then it became statistical analysis, then analytics, then I changed all the names to today. Finally, we ended up with data science. data analytics became data science. Doesn't matter what the names are, subject is still the same. See, in the 1663, there was a plague. Plague is caused by rats. But then the point is, they used statistics to localize where this plague was occurring. That was the important part. And then you seal off those areas. Even now, when we have COVID, the clusters are not identified. Instead, we seal off, lock down the whole city or state or whatever it is. But they did apply a lot of knowledge here. Then in 81, the US Census Bureau, actually that was one of the early computerized attempts, they wanted to take the election using punched cards. And Herman Hollerith came out with this punched card, again, data being represented in machine form. Of course, it's not binary, but it's a Hollerith code, and that was the next attempt. Thereafter, things went faster. Of course, in between, you'll also have the other things like the London cholera outbreak and so on. I just took the important ones. This was because it's very old and I skipped all the ones. 18, 19, came straight to this, what we call Hollerith code, a punch card as it's called. Then magnetic storage, it's all tapes, big tapes. Then you came into the data for transmission. World War II was a serious attempt at encoding, decoding. Today, of course, we call it encryption. It's called cryptography and so on. Anyway, this was in the World War II. Most of the operating research, operations research, systems analysis design, encryption, they're all offshoots of the research that went on in the Second World War. Then came the computer part of it, built out of valves. And the first time when people said we can do something electronically instead of mechanically. Up to there, everything was mechanical, they're adding machines, there all kinds of stuff. But this is the first time when no wheels, no moving parts, something electronic was happening, and you got answers like 1 + 1 is 2 and so on. Then came the privacy issue, this national security agency, NSA, equal to our NIA in India. So when they were collecting these fingerprints and income tax returns, the people started asking questions. How do you know? How do we know that government will not misuse the data? Like same like today, privacy. That was the first thing there. Then we had the internet. We can take both of these together. The ARPANET was the defense part. NFSNet was the internet backbone. That's the backbone even today. Then 65, when they got into this, actually, if you see here, this was the beginning of the protests for privacy, this United States NSA. Now we have people trying to, I mean, not we, the US took people's personal information like your income and so on. And then the question was, what will you do with it? Will you misuse it and so on? The fingerprints also ran into trouble. Of course, now we understand income tax, Aadhaar, all that. Then came the desktop machines, the PCs where you didn't need programmers and data entry operators. The owner did whatever the owner wanted to do, right from playing games to spreadsheets. And today, even in SQL, you'll be doing it yourself. You're not having a support of a computer staff. Then came other types of, today big data, we call it unstructured, audio files, video files. Now we are running into thousands of formats. Earlier it was very few, but then everybody thinks there's a new format, a better way of doing something. Should we learn all these thousands of formats? No need. We got Hadoop and all those things which do it for us. Then came the concept of the World Wide Web. This just started, but then Gosling, when he came out, that was actually 93 or 94. With the HTML, then it opened up a different world where today all your search engines, they don't search much. About 30-40% of the internet is what it can search. It'll search web pages only. It can't find the databases, text and archives and so on. But anyway, the trying to develop such engines also, you have. Hackers use them quite a lot. If you're interested, you can have a look at deep web, not dark web, deep web, DEEP web. That's where all the non-web page kind of data can be searched. And then multiple technologies they got in. So this has now become micro electromechanical. Of course, it's too long a name, so they just gave it a small name. They call it Internet of Things. Now, what does that mean? It means you're today, of course, you're used to it. Your FASTag. Even that's not a good example. You got sensors all over. You take a phone, for instance. It knows what you're doing, where you are, etc. You got cameras. You got sensors for heat, sound, pressure. They keep on transmitting information. So in real time, you get a lot of information. So today, robotic surgery is possible. Various things are possible. And what does it mean to the auditor? It simply means you have more data to be vouched for, or particularly those in the assurance field. There's a lot of data, but in internal audit, it becomes more complex because you'll be dealing with operational data also. Then, of course, came this lot of data was getting stored. Some person, Roger Mogalas, called it as big data, just a name. Not that it existed only after 2005. Data was always available. I mean, phones came much before 2005. IoTs also came, but they were expensive. Today they become very cheap. Very cheap means you don't pay for an IoT. It just comes along with the equipment. I mean, you're just stuck with it. If you want, you can turn it off, but that's also getting difficult nowadays because there are no switches on these equipment. They're all software driven. Then came the cloud concept. So the on-premise data centers disappeared. In India also slowly they're disappearing. When somebody asked a question on QuickBooks, that's a cloud-based accounting package. So you got infrastructure as a service, just like it's like a building network, everything, but you have to put your own machine. Platform as a service, machine also included with OS. Software as a service, the application itself was there. So QuickBooks would be a software as a service. Now, when you come to big data, actually the definitions are all little dicey here, but specifically it doesn't have to be big and it doesn't have to be from outside. It can be the company's own data for a period of time, may not be very huge also. So it is possible. So when you look at that kind of stuff, see, you will start at 3 Vs, 4 Vs, 5 Vs, now they went up to 7 Vs. It doesn't matter. What we are talking about is, can we handle a large volume of data? Yes, we can, because your hard disks have become very big. So I'm talking about laptops, small machines. Giant machines, very, very huge. See, Domino's in India alone, they generate about 4 petabytes of data every day, and they analyze it. Of course, they may not store all of it, but they in one day, end of day, it'll be so much, and they analyze it. If you bought Domino's pizza, maybe if you didn't buy again, you'll get an SMS, we are missing you, and we got a Wednesday offer, and so on. So volume is not an issue. Then comes the speed at which you're getting data. Today, do we have to buy data? Not necessarily. A lot of data is free. It comes from different sources. Only thing we have to tap it correctly, but it's available. This is another problem because first of all, you don't know where the data is going, and like who's handling what data when, and is it public data? Yes, this is an issue. So different countries are passing laws, privacy laws. India is stuck with it for the last 3 years. They're not made it an act as yet, but the bill is available for review. And Sri Krishna committee also, their findings are also available. Then comes the type of data. You get lots of types. You get pictures, PDFs. You can get all kinds of stuff, graphs. Not those text files. Apart from that, you get a lot of data. For instance, if you used Google Photos on your phone or any device, you look at a person's face, then it can find all pictures with the same face. Well, that's big image search. But you can do CCTV footage, can be scanned, image processing. A lot of things happen here. All types acceptable. Then do you trust the accuracy of the data? Because in that CIA confidentiality, integrity, and availability, integrity is what we are calling as accuracy here. From the auditor's perspective, he talks about various things, and one of them is the validity of the data. Can I trust the data? Well, you can. Actually, according to most of our statistical analysis, if 66% of the data is correct, it is enough. That's 2/3 of the data. We say 1 standard deviation. You don't have to go to 95, 99 and all that percent. So yes, we have fairly accurate data if it's 2/3. Sometimes only 20, 30% is accurate. Then you have to simulate those missing figures. It's called random forest. You can create the data. Then you have to turn all this into value. How do we turn it into value? That's where the audit becomes very difficult. If you look at audit data analytics, I'm not even talking about AICPA because most of the audit regulators worldwide, global, I'm not talking about any specific thing, even ICAI, AICPA, UK, India, whatever, we have not brought in technology fully to convert this big data into hardcore values for audit. But we are trying. So if you have time, you can also read things from other fraternities like statistical or marketing or supply chain, which will help us in the auditing. So when we look at this, okay, the fancy name today is data science, it's the same thing. Where we have to look at statistics and machine learning. Actually, today my point is you can learn both because you don't have to learn form. You got, let's take a calculator, a simple calculator. You find a square root. I don't have to know how to find a square root. Press the button, you'll get it. So when I say statistics, this is not those old ancient formulae you write and memorize, not necessary. It is basically what do I use it for? For instance, we all know a square root button exists on the calculator, but if I use a square root, supposing I enter 5, I get 2.414. What does that represent? We say it's a square root, but what use is it to me? So that's more important. Machine learning, of course, we have to learn a few algorithms and what they do, not the equations, just the concept of understanding. Software engineering is one part. I know it's difficult. Maybe we could park this for the time being. Complex data we can all understand because when you do an audit, you may see photos, you may see geotagging, when you're physically doing it. You may see records, bills, vouchers, you may hear audio file, you may watch a CCTV stuff. You have done a lot of work with complex types of data, but now we are going to bring it into a computer and process it instead of looking at it manually. That's all the difference. Now, I leave all this out. I'll just make it simple. Descriptive analytics means what happened in the past. It's like our general audit post-mortem. Somebody spent money without a bill. He didn't provide the right amount of depreciation. That's all descriptive. Of course, statistically speaking. Predictive is what they should be doing. I mean, what will happen? Not what they should be doing, but what will happen if you continue this way. Prescriptive is what they should be doing. And today, when we talk about auditors bringing value to the management, corporate governance, so many things, we are talking prescriptive analytics. That is, what should an organization be doing? And of course, there are a lot of case studies. If you have time, please read them. Nothing to do with audit. These are mainly governance or what we call business case studies, where companies try to change, they don't change, they fail, or they change and then they fail. So many things we have got. So prescriptive is what is it they are not doing? Are they listening to the right people? Auditor is the right person to listen to. Of course, he has to do his work. And if you look at the analytics here, I said I'll skip this, but just quick. One is text is all the words and we write, language. But also it means speech. Every time you call a call center, they say we're recording this for some training purpose. They're not training, they're actually recording it for text analytics. So what they do is they keep on analyzing the type of calls, so done by machine software, and then they find out the most common complaints and then they attend to it, or they make a bot which will chat, or they make a IVR, it's interactive voice response, so that question gets answered through your pressing buttons. Sentiment analysis, we can almost predict what people do, what they would choose, what they will not choose, including elections. But sentiment analysis for elections is banned because they say you're influencing voters if you predict the result too early. Social media now, of course, even the US consulate does a social media audit before they give you the visas. But today in audit, this is becoming important because of marketing, bad employees writing bad blogs, those kind of issues. Network analytics is, of course, two types. Hardware networks is electronic connections, whatever. The other network is actually gone back to social media, where your friends and all that, but logic is the same. Type of equipment is different. Geospatial is geographic. Maybe we studied it as transport assignment, nearest place to nearest place. Today, geospatial basically is the same thing. And location-wise analytics. India is very peculiar that way. In fact, most countries study India as for the geospatial because we have a lot of differences, like even a cool drink. Some flavors will sell down south, some flavors west, some flavors north. It's a lot of places, different climates, languages. Image today is, of course, all your CCTV footage. Of course, they use artificial intelligence for this processing, but they process everything, pictures, images automatically. Where does it place the auditor? Now, nowhere have we mentioned data like creditors and whatever the cash book and journal entries. They're not mentioned that at all. So can you really do an audit with all this? Statutory audit, of course, it still assures the financial statements, which are even there, fraud, window dressing, maybe some other class you could study. They do this, Benish, Olson, etc. And with the ratio itself, you can find out whether the accounts are good or bad. But this is more for the auditors who are looking at operational audits, or looking at internal audits, value for money, performance. A lot of this has to go in. Statutory audit is just only certifying what we call financial statements. May not be too much, but maybe we don't know. But it all depends how our company law and the corporate governance gets interpreted. But that's only for companies. Partnership individuals may not apply. Now we have to get into the terminology now. Now Hadoop is actually a database because specifically developed for data which was never called data. Data for us meant alphabets, digits, special characters, and so on. Now with complex data, what we mean is what we mentioned earlier, the pictures, sound files, and all those things. Now this multiple data sources, we understand. Batch processing, we understand. Fixed periods of time. Parallel execution means parts of the same program are running on different computers. Now, is it possible? Actually, of course, this idea was all there. These are all basically computer science stuff. But hackers took advantage of this first. They started doing distributed denial of service, which means for multiple unsuspecting computers, they placed their bad software, and from multiple unsuspecting machines, they used to attack one particular machine, let's say White House computer. So those fellows really learned, or rather brought everybody into this. I mean, using this parallel execution, of course, today use it for good stuff, but see, any one of these we are studying is always used by a hacker. So, and then spreading data over a cluster of servers for quick processing, immediate processing. For instance, drone attacks. Again, bad example, but they do it. Now we are trying to use it for good stuff like pilotless planes and pilotless trains and self-driving cars and all that. Okay, now anyway, what we're trying to say is you have to look at complex data because India is one of the fast growing countries, third largest economy, fastest growing economy. Now, if you are going to automate the way we are doing, like we had an old TV, you tuned it manually, then you had to tune it through a menu with a remote. Today, you don't tune anything, you switch it on, auto tunes itself. Now, is the auditor's job gone? No. Does he have to look at data? No. Does he have to look at the algorithm? Yes. Now that is where we are trying to, why are we studying all this? Because we need to move on to this benchmarking and algorithm kind of stage. So earlier I told they study your text, they study all this stuff, index building, graph creation. Graph creation is actually called graph databases. Neo-J, okay, that's one of the most popular graph databases. Pattern recognition, this is how we get suspicious patterns, and like a credit card usage, you get a phone call, or even if your Google account, it says open from an unknown device. Okay, that's stuff here. Collaboration means a lot of people working together. Collaborative filtering means filtering happening over multiple requirements. I'm not using the word user because in computer science, user means it's a human, could be a program, could be another machine. Machine to machine, they can work. A program to machine, a program to program, they can work. Of course, humans can always work. Then prediction, predictive, whatever models we're going to talk about, sentiment analysis, and so on. Last, we end up with the auditor's favorite term, risk assessment. All this helps you in risk assessment. So it's no longer the standard COSO forms we are using. We have to upgrade that to the next level. Already there are 2 publications with AI for auditors for risk assessment. Okay, what it means is if you got small volume of data, don't use Hadoop because it takes advantage of parallel execution. Use Scikit or R or Python, whatever you like. As it gets bigger, use Hadoop. All these are open source. Python, R, Hadoop, etc. all open source. So I'll just explain this diagram as simply as I can. Now, what we mean by a power user is somebody who's contributing to this big database. What we mean by a casual user is someone who's using the information from the big database. These two have been identified because it happens anywhere. Newspaper, somebody contributes news, etc., etc. Casual user reads the paper. You have a TV program, somebody is putting so much of content, script, etc. Casual user watches it. Okay, take some example there. Now, what is it we are talking about? So the power user is uploading a lot of stuff. Analysis is okay. Sandbox simply means not connected to anything outside. That's all it means. It's safe. I mean, that's what it means. Then you're taking data from the web. Okay, these are all the types of files. We can get data from feeds also, like Reuters, Bloomberg. You can get data from satellites. You got a whole lot of data available now. So all the data comes in. Don't worry about this Hadoop cluster, just ignore it. All kinds of data we pick up. Is it only from the net? Not necessary. IoTs also give a lot of data. So what exactly is an IoT? If you have one on the door closer, one on a refrigerator or wherever, or many of you may use Android phones to control a lot of things today, like AC or whatever. The data can go out because if you don't have a network, it's fine. But obviously, we all have some Wi-Fi or internet. Data goes out. So all that data we are going to collect, even from traffic lights, toll booths, wherever the data is available. So all that comes in here, gets into a large storage called data warehouse. Then comes all your machine data, operating system, etc. And then there is a cleaning up machine. Streaming is basically pushing the data continuously. Then you're converting it into some business intelligence. Like you may, like Netflix will tell you which movies are watched. Or if you watched a movie, it'll tell you which other movies are like the movie you watched. You watched a bank robbery, it'll tell you what are all the other bank robbery movies. So that is what the casual user wants. Not necessarily data user. He can be a movie content user. He can be anything. I mean, he wants to find Google Map, most crowded road, whatever. We're not defining this to anything. But what is an auditor going to do with all this? He may be a power user, but he will always be a casual user because we need a lot of data from outside stuff. There's an insurance claim. Olden days, what they'll do is they'll go to the Met office, meteorological office, get a weather report, then compare it, then allow, disallow, rain damage. Let's say container carrying some leather goods got damaged. But today you don't do all that. You can get all the meteorological data, satellite images, all online. You can also check what is the rainfall. You can check whether the type of leather actually gets destroyed by rain or moisture, and then come to a conclusion, and then decide if the insurance fellow is cheating you or is, genuinely refuting your claim. Now, where did you go to get all the data? Somewhere here. You didn't go to the meteorological office, the Central Leather Research Institute. You didn't go anywhere. You just picked all this up and put it together. The only thing is, from audit perspective, Google is not giving you all the best information because today knowledge has become so deep that the people with real knowledge are not contributing on Google. So after certain level of usage, you will find Google is useless. But that's okay. That's why I said look at deep web. And maybe we can create our own knowledge bases. We can contribute to the deep web also. But for normal use, Google is very good, or any search engine is good. But slowly you may have to move to other sources also. Now we come to the Hadoop system. I'll again explain this in the easiest way I can. Now you have a lot of file here. Now they contain different formats, different things like music, whatever. Now you have to just accept this. It's called HDFS, is Hadoop distributed file system. Okay, rest of it you can just ignore. That's fine. Now, what is a file system? See, for instance, we use a file system called NTFS. NT is the new technology. There was a Windows NT. It was not available now. It was a POSIX standard. It's more like Linux. So, well, they gave the name NTFS. But if you're the older one, it's file allocation table. We call it FAT32 or something. Now, each of these will need a different type of storage, like pictures, music, whatever. I mean, different things. Now, once these are all, for instance, YouTube, we get so much of junk on YouTube. How can you put everything in one place? You can't. So think of these as YouTube content, Facebook content, or you can go even much deeper and think of these as content you're getting in Netflix, or say, for instance, books and music. And actually content management is a huge thing now, distribution rights, royalty, IPR. Okay, think of all that. So we got so many different types of storage. Then let's look at what we want to do. Now, what we want to do is we have to process it. So MapReduce summarizes it, and so do tests, and Spark and Storm are for streaming data. Streaming data means the data is flowing continuously, like from servers, from railway data. You can actually see the train moving. If you share your location, somebody can see you moving on a Google map. It is streaming data. But these are more like periodic data. That's why we said parallel processing and batch processing and real-time processing. These are real-time, this is batch. Okay, we have summarized it. So Yarn is a broker software here. Yet another, it's only just trying to manage the resources. From here, we got to have these third-party people using BI tools with business intelligence, graphs, water visualization, storytelling, etc. You got all your data analytics stuff here, Java, Python, whatever. Including, you can put anything, including SQL. Okay, and then we have the scripts which people write for the streaming data, and you have these indexes which help in quick searches. Like I told you, if you buy something on Amazon, you could be profiled for the type of vehicle you're driving. So I don't know, sometimes you go to a car park or some mall, they'll ask you silly questions, some lottery somewhere, your name, etc. Then they'll ask you questions like what car you drive, what you do. So basically they're collecting too much data. So they collect all the stuff, they index it. Okay, what does it mean to us? It means we don't have to do benchmarking. Of course, we have to do benchmarking, but somebody has got all this ready. Are we ready to use it, particularly in terms of BI and analytics, auditor point of view? For those who do streaming like firewalls and content management, particularly those who do film audits, particularly now we have this content streaming, books, royalties, so many things are going on. Then you have to obviously work with streams also. So if you come here, we said open source. You may be wondering why I'm promoting open source, because open source is written by people who contribute their time voluntarily. So they do a very good job. Paid programmers are usually have more bugs than the open source, and open source bugs are fixed immediately because a lot of volunteers will be there. Some of you may also want to join, not necessarily programming open source like GitHub, SourceForge, but you may also want to be on GRCs, governance, risk and compliance framework contributors. There are a lot of openings, OECG, etc. So when you do that, you got the best talent. That's why I'm pushing this open source. Of course, many companies do not accept open source because IT people are not knowledgeable. I mean, we can't criticize them, but I mean, we can't do much about it because the management will listen to them. That's why I say take a dump and you do whatever you want with it. They are happy with the dump because you're isolated from them, but you can get a lot of insights into the data. Now, what is a Hadoop thing do? One is your yarn. That's the yet another resource negotiator. Just because in Unix there was something called yet another compiler that's called YAC. All these apps will be mostly Linux apps. So they'll have this almost same nomenclature. Yet another resource negotiator is basically here. It's brokering between all these modules and the actual data. Now, should all this be in this one big blue thing? No. Some of this data may be in different places. For instance, you could have some of the data as movies in a content server like T3 or something. Some of these could be books that may be in a Kobo or a Kindle server or Amazon server. Some of these could be photographs, maybe it's sitting in Google somewhere, can be anywhere. I mean, so these are pictures. I'm just trying to explain in a simpler way. Then we have the Hadoop file system, which I said you can accept. Then these are all the execution engines. You don't worry too much on them. This Pig and Hive, and I'll expand on these a little bit just for us to learn. But those are adventurous. You want to learn. Plenty of all is open source. You can download or you can get into a cloud environment and try it out. Okay. And then we need to look at the distributed file system. What do we mean by this? Now, I don't know whether we have really tried calculating YouTube, Netflix, or whatever, Hotstar. So many of these people are there. What is the volume of content they will be carrying? What is the volume of serialization that, so for instance, I'm watching it on the TV, then you're traveling, you see it on the phone, then somewhere else, there you stopped, it restarts. You're not the only person, there are millions of viewers. How many millions of records, serialization, what they did, where they stopped? I mean, the same movie when we watched by 1,000 people at a time, how do they manage the data? If you went for an audit to a bank or even worse, a company, they'll have 10,000 users, big one, Indian Oil. You may have less than that, you'll have 5,000, 3,000, 100 users, they can't manage. The entire access control will be a mess. But these guys can't mess because of money. So otherwise, some fellow will be watching the movie free on somebody else's account. They can't do that. So this is where, or even Airtel, phones, Geo, they block your account the moment your money is over. So there, they even say, once this can also be a telecom thing also. It can be anything actually. So anyway, right now, just go with simple examples of content management because it's easier to find things on the internet. Telecom is a bit more secretive. So anyway, one is you can scale it to any level. You can use any number of formats. You can partition this across any number of servers globally. And you have, we say normally BCP, one main, one secondary, that's called replication or a backup. Here it's triple replicated automatically, which means two breakdowns can be accommodated. Disk failures, whatever servers. So we need to understand that this HDFS is, I mean, somebody wrote the filing system, we just use it. Then execution engine wise is the parallel processing. You can run these off multiple servers. So maybe if you're watching a movie in a train or Hotstar, you might have left one server and switched on, or you might have got connected to another server without you knowing it. Okay, then engines always mean software. So I'm just making it as simple. I'll share this PowerPoint. Those are interested, read it. Those are not so interested, at least the bold part, you please read. Then the parallel processing is achieved by taking the program to the data. That is the most important part. I am logged in. I have an account somewhere, whatever iTunes or something. My iTunes software will find the content, see what I did with it earlier, to how many bytes I watched or heard or whatever, and it will pick up from there, and then the application pushes it. The application is gone. I mean, it's finished. Now, this was a totally reverse way of doing things, where applications loiter on the internet rather than the content. Of course, after that, the content will come to you. It's called streaming. and all for entire India, they may have one stream, and then it will get distributed. To give a simple example is if you are on cable TV, regular cable, that box, set-top box, only one wire will come to the box and one wire will go to your TV. But depending on what you did with your remote, you see different programs, which means that one wire or cable is carrying at least 200 channels worth of information. You will get only whatever you want to see. So it is possible, whatever I'm explaining. Instead of 200 channels, you make it million channels or 10 lakh channels. Now the map reduce tries to summarize the data. So when it says steps, map step on all the nodes, okay, it's too complicated English. I'll just make it simple. We have a picture which I'll show you. See, this is what map reduce does. Now we have got some data, some words, English words, deer, whatever, bear, river, etc. Now first what it does is start splitting. Let's say 3 and 3 and 3. It's only a simple diagram. Splitting can be based on complex algorithms. Once it has broken it up, then it starts counting the number of occurrences. Suppose here each one appeared only once. Then it starts putting them all together, common items. Maybe we have done this in Excel when we sorted or find duplicate or unique or something. So then it's got the bear, the car, etc. Then it counted, got the reducing done. And then the final result is what map reduce produces. Now this happens in real time at high speed. Of course, computers are fast. The main thing is real time. So at any point you will know what is happening, where your load is higher, where it's lower. I was talking about content. Of course, we'll know if the same movie is watched by more people, it will start distributing it to other servers. If you take something else like telecom switches, if certain switches are getting loaded, like say Chennai, Mumbai, traffic is heavy, but Chennai, somewhere, Mysore, someplace, went Hyderabad, Warangal, then Mumbai is not so crowded. It'll actually start routing your conversations or your voice, whatever you're doing with video conferencing across those longer routes automatically. It'll charge you the same amount, but it tries to not to lose the traffic. So it keeps using all idle circuits. That's why you need to have this, I would say summarizing. MapReduce is summarizing. If you're doing a TRAI audit, maybe we are not using big data, maybe we are, but maybe normally we do the switch audits. Then you may be using some software which is summarizing those switch data. So that is possible. Now TES is an alternate to MapReduce. So you know what MapReduce does? TES does the same thing. Spark accelerates the application execution. Now, how does it do it? It basically works in parallel and in memory. Now, see, one of the things is when you take your PCI DSS, you're not supposed to store credit card data somewhere. You take HIPAA, you're not supposed to share the medical data. Okay, there's so many rules. Of course, we are waiting for our own Privacy Act. Right now, we work with the IT Act. Now, what happens is if things have to be checked real time at high speed, I don't know if you had this experience with FASTag. You can't drive through a toll gate. The guy still has to do some silly things because it's not fast enough. But the whole idea was no congestion at the whatever that. See, today if you have an RFID or whatever, that works in real time. Production systems, humans carrying cards, it moves. So we need to look at something which can do a lot of work at very short cycles, very quickly. Then this is an execution engine for streaming analytics, a Storm. Okay. Now, why do we have to work with streaming analytics? I gave you some examples of some logs and so on, but it's not always logs. Now, if you take railways, for instance, now all the trains are running, and if you take junctions like Vijayawada or Warangal or something, it's terribly congested because they're changeover junctions. Now, at that point, if you're railinfo.com or whatever that software you're using is able to give a real-time analysis, then it needs to get data flowing all the time. And this can particularly be like your Ola or Uber, like your taxi is coming in 2 minutes. They have done not just a distance estimation, they've also done a traffic estimation. route estimation, traffic estimation, and they're given some number. Okay, that might change again. So these are why you would do a streaming analytics. Swiggy does it, and IoTs are placed on the Swiggy motorcycles or scooters. So the insurance policy starts the moment the Swiggy man follows the map. It stops when the delivery is complete. So if he deviates, they lose the insurance, because that is not an insurance for the bike or the driver. It is for the journey. Each journey is insured. If the bike is used for something else, it is not insured, not by Swiggy. So this doesn't matter where, what it's written in and all that. Today we have so many tools, audit tools. They call it software testing tools, but I'm calling them audit tools, where you can actually take an application and study it. Like if you have time and if you're doing mobile apps and web apps, BURP, B-U-R-P, gives a very reliable risk analysis of the code, both for security and speed, and you can definitely include it in your audit reports. I mean, audit reports. Okay, so today testing tools are the same as audit tools, so we can use them. I mean, they didn't say it was for not to be used by the auditor. Okay, then we have this SQL processing. Now, see, we did some SQL just earlier, but see, when you go into large stuff, we say no SQL. It's not an SQL or whatever it is. But let's say we are auditors and we are not going to learn complex software stuff. We can still use SQL, but we need to have the right interface to it. So Hive, all these are open source, HIV. You can actually, schema is that structure of the database. So we talk about logical schema, conceptual schema, physical schema. Don't worry about it. It's just a structure. I told you table, no, same thing. Think of only the table, leave off the rest. Okay, or a table, okay, fine. So you just think of the table structure, forget this complex data, use a normal SQL and work with this Hive software. So the question was, will it work with ERP, etc.? I said, all of them will have a database. But big data may have something more than a database, and Hadoop kind of distributed file, it doesn't matter. Let's say you now have to work out a royalty for a particular author whose books are on 2 different sites. How do you check the royalty? You have to manage the normal SQL. So use the Hive and finish it off, because you can't see other people's books. I mean, that's another problem. Now, sometimes you club your purchases. Say on Amazon, you buy from 2 different people. You make one payment, but you have been appointed by only one seller to do the audit. You're not auditing the other seller. Purchase will be 2 sellers clubbed, but you'll still have to use your SQL. Hive will be there. Of course, there are paid software, plenty of paid software. I'm talking with open source right now. And you use the SQL and you pull it out and finish your job. Then the search is mainly like how your web search engines work. It's called crawling, or they call it spider programs. The indexes are built all the time. They are built continuously, and they are built as JSON files, the same as you get from your download for your income tax, TDS files, 26 AS or something, whatever. Okay, anyway, these are JavaScript files, can move around, easily processable. You can put them on websites. So indexes are also maintained for these large databases, because you may be appointed as an auditor only for one function of an organization. So let us say we are working with some payment gateway, but you are working on behalf of a DISCOM, Tamil Nadu Electricity Board, and they're taking payments from so many things, but they have few payment gateways. You are allowed to audit only the TNEB's data from that payment gateway. You can't audit the gateway, you're not the gateway auditor. Neither can we look at all the transactions in TNEB. They want only payment-based receipts alone to be reconciled. Because now, the rules have changed. Unreconciled accounts have to be reversed on a T+1 basis. So now that puts a lot of pressure on the organization. Usually it's dumped on the auditor. So they say, you do it. Or should I can consulting assignment, whatever. So then the index makes a lot of sense to filter out stuff. Now, what we have to use, I'll just go to the next slide so it makes it a little easier. Now, depending on the size of the data, let's say it is less than 10 GB. Small data methods means, okay, starting with Excel, you can move up to your Power BI, Tableau, Click, Nime, any of those one-off tools, you can finish because the machine also won't face a problem. But if you are going to move up to 200 GB or more than 200 GB, then the question is, what is your query size? How much data are you going to really get back? If you're going to take one element at a time, it is going to be big storage. Now, the problem with this one element is each query will take only one or few records. Okay, let's not say one, a few records at a time. I'm looking at only bill payments made in the last half an hour using Amex cards. Amex are a bit rarer cards. Visa, other cards, Rupee and Master, you may get more transactions. Or we are looking only at non-COVID patients admitted in government hospitals, which will be a lesser quantity. That's a big headache for the query because you run 100 queries, you may end up with 150 records. But if you're doing streaming, then you're passing over the entire data. But again, you may have multiple passes. A simple example, we got 100 students' marks. I want to find the average and those who got less than the average. First pass, I add up everything, I get the average. Second pass, I take each mark and compare with the average. If it is less, okay, that record is returned. It's a small example, but streaming can have more than two passes. I'm just giving some examples. Then multiple passes over huge chunks where you don't care about the time. Batch processing is fine. I mean, we are just doing kind of analysis or postmortem. But if it is like I told you, switch data and those kind of things where immediately you'll have to switch. In fact, the industry standard says you need to predict half an hour before. That's why predictive analytics comes. That switches may be overloaded half an hour before, 30 minutes. 30 minutes is a lot of time for volatile traffic. But still your prediction algorithms, of course, they will learn. They are machine learning, supervised learning. They will learn, so they improve themselves. And sometimes they're able to route even an hour in advance. Because one of the problems is when you're routing from India to US, you have two routes. You can go west or east. East, we have good switches, bad switches. Malaysia now good switches. Hong Kong, etc., good switches. You end up in Taiwan or Thailand, somewhere you're lost. This side again, if you're going via Gulf, it's good switches. Europe is okay. Not all Europe. Poor countries in Europe are useless. So learning algorithms, you got most of our traffic may go through Turkey, it may go through Greece. Now those switches are useless. So I mean useless means old. So you will have to load balance the traffic. All this happens in real time. So for us, but for the switch company, they call the auditor and say, are we optimally using this in India, TRA as in India itself? You're not supposed to have a call drop, but we all have call drops. We are not, Indians are very tolerant, but if you strictly follow the TRA, as an auditor, you would have picked up data, number of call drops. And unfortunately, that data cannot be hidden. It's there sitting in the law. Now, this I know is a very tiny picture, but I'll try to zoom in. See, if you look at this, what we are trying to say is, what is the type of analysis you want to do? That's your first decision. What processing methodology? Is it predictive, analytical, query reporting, or is it others? Now, if it is analytical, again, is it social networks? Is it location-based, the geospatial? Is it features recognition? Text analytics is mainly our voice and text, statistical algorithms, etc. Then if it is others like 3D reconstruction, whatever. Now, this is on what you want to do. Then comes your data frequency, on demand. Otherwise, continuous feeds, real time. Time series means over a period of time, share market, whatever. Then data type, again, metadata is description of the data. We used to call it data dictionary, but now it's data about data, metadata. Master data, we know. Historical is from the data mart or data warehouse. This is like old data. Transactional is happening in real time now. Then content format, all these stories I told you, there's so many, this doesn't justify, but there are so many formats we can use today. Then data sources, where are you getting it from? Web, machine generated, human generated, etc. It can go on and on. Now, if you take data consumers, is it people? Is it a business process? Is it other applications, etc.? If you look at hardware again, you buy standard hardware off the shelf, or is it like built, very sophisticated parallel processing kind of systems? Okay, so this kind of summarizes what we want to do and how we want to do. But when we look at these charts, we also understand another thing. For instance, today we have this inline XBRL, INLINE, where your balance sheets or whatever, your financial statements, when they are on the internet, you open it, it looks like a normal HTML, you can read it. But if you click on it, it'll open up the XBRL information. And statistics, actually, you can download that software free from SEC site, Securities and Exchange Corporation. SEC, the US, like our SEBI. That software is free. India has not actually mandated it, but they are experimenting with it. You got all the other stuff, all the ROCs, XBRL, MCS, SEBI, whatever. Anyway, you can look at this SEC, which is a little ahead of time, but we can look at it. At least for India, we have not taken those classes, but those who are working with the US listings, okay, wherever, if you're got foreign investment, you'll be looking at it. If you download that software, you can play with it. It's free. I mean, it's open source. What you find is, or what they found was, more than 90%, I think it was 93, I'm not sure, but more than 90% of the users of those financial statements were software, share market brokers, technical analysts, all kinds of chaps, including money launderers, the whole bunch. But actually, what is happening is when you have some content on the web, humans, people really read it. Machines are, they call it web scrub, are the last people who they read the web pages and they try to make sense out of it. So all those pages picked up first, put it over to you, because the most time we say website fellow didn't update. You don't need website fellow, you can automate the updation. Today we have LODR says if there's a critical incident within 2 hours, your website incident. I don't think in the middle of the night in a flood of fire, find email to update it. Anyway, what point is we got the law, we copy from different countries. But if you're going to wait for a human to open the page, update it, put it on the web server, it's not 2 hours, it's talking more than that. Those comfortable with that will know these problems. Quick look at these use cases, because I have to convince you that is all working. Now, electricity companies who want to predict power consumption, of course, see, long before this, these were using it. It was not called big data, it's simply statistical analysis. Now, in US, where the gas is piped to your house, you are lucky, no problem. But when you're a little outside these piping areas, they'll bury a big metal tank in your backyard or wherever, and they'll fill it up with this gas, propane, whatever. use it for cooking. Most of the luxury cars, all of them without exception, were diesel. So there are, what you call insights, where rest of the world, a luxury car is always petrol. Poor man and trucks, lorries, buses, they are diesel. So we do come across these. So power company predicting power consumption is nothing strange. So we know all these sensors, they call them SCADA. If you're doing this non-conventional energy like wind, geothermal, whatever, solar, you'd have come across these units. Of course, as auditors, we see all the monitors and screens, and then we take the meter reading, accept. But you can go there one step further, try to understand it. So that will make a lot of difference. Then insurance companies doing risk analysis or risk assessment. Maybe you've already done this in insurance. They have premium frauds and they have these claim frauds. The earlier means I'm talking about 90s and 2000, the frauds were all on the claims. But now, because of course now we can use a lot of statistics and tools, the frauds are all on the premium. Okay, anyway, this is a new thing. The companies are also struggling. Anyway, just to add to this, customs people, they always had a problem with under invoicing. Major problem. You buy for $100, you'll bill it for $50. Now the problem is excess billing, over invoicing. It's used for money laundering. So you buy for $100, you bring it here at $1,000, remit the $1,000, 900 is laundered. So we come to a lot of insights. I mean, if you're working with them, you'll understand. That's why GST, they said back to back, we'll check and we'll catch you. Banks, if you're doing international, yes, Basel 2, 3, of course 4 is there, but India has not accepted it. Banks do a lot of predictive analysis, but in India, what has happened is banks are like pass-through items and nobody cares. But maybe now with this bad bank business, it may change. Particularly sentiment analysis, churning, NBFCs use it a lot, and post office uses it a lot. All these things. Then fraud detection, of course, is massive, both by government and by auditors, and also by a lot of consultants, forensic consultants, audit law firms. There is a lot of fraud generation software, which means all your data is pulled out and analyzed. Okay, I won't go very deep into this, but any questions you have, I'll answer. Then we have marketing, which is also one of the largest things we need to understand. Basically, it's sentiment analysis and emotion quotient, which is used. What type of people will buy what, when will they buy, how will they buy, and a lot of things. In fact, in one of the early studies, it was shown people in the rural places use the ATM more than people in the cities. They don't have access to branches and they're pretty comfortable with the card. Now, with these 10 forms of cashless payment from India, micro ATMs, micro POS machines, there's a USSD or something. You do it without a smartphone. They are very popular in the rural areas. Here it's not popular. Cities not popular. Then customer churn, which is like man borrows money for a business. He's got teenage children. This fellow will go and give bank loan for studies. A kid comes to college, they won't give him money for a bike loan. So they're trying to make sure this customer doesn't move out of that organization. So that's what they mean by customer churn. This is your loyalty cards for departmental stores, or this can be your airline loyalty, or it can be anything. So you do a lot of traversal and identify patterns so that you keep people in your control. Okay, they also get a lot of insights. I told you, give a few examples like cars being diesel and something like that. But we get a lot of bigger insights when we work with patterns. For instance, in this lockdown period, gaming companies made a lot of money from these youngsters. So suppose we're studying with their phones, but we're playing games. So that was also there. Then recommendation is, if you did something, what else would you do? In the old days, it was called elastic demand, inelastic demand, something. You bought a pen, you'll buy ink and so on. In fact, most of our statistics can work with economic theories also, economic theories. So the one of the predictions, recommendations is not from the same shop. It doesn't have to be, you may buy a book, then they'll try to sell you a bag. So they're not related, but the portal is trying to do its best. So that is also possible. And the other recommendation is you got a heart problem, maybe you got cholesterol, diabetes, something, then it can also suggest what to do. And today, a lot of recommendations, they work with older people, sensor-based, and it used to be sensors, but today it's your Android phone or these wearables, like watches and wristbands and armbands. They transmit a lot of information like heartbeat and blood flow and oxygen, something. Even the latest Apple stuff will even check your sugar. They're able to check the sugar from the sweat, not from the blood. So it'll immediately inform your hospital that you're going in for some problem like a stroke or even before you realize it. The ambulance is there, and it makes a lot of recommendations. In fact, if you read medical predictions, patient predictions, it's very interesting. But in other part, location-based ad targeting is mainly it's all geotagging. This is not just for ads. I mean, it can be for anything. Actually, we have a lot of data on this geotagging because when you any data you pick up today is geotagged, and now people are using attendance also as an app on the phone, which means you're getting location of that person, and from that location you'll be able to figure out a lot of things. Anyway, privacy, yes, but we still have to wait for the law. Then threats, of course, we identify a lot of anomalies. This threat is not business threats and human threats, but also network threats, traffic analysis threats, anything. I mean, the threats are not always like, I'll murder someone or something, but threats can also be in loss of business, stock out situations. Those threats can also be identified. In the real-time analytics, I'll just go fast here. Now, the streaming data is the only technology available. It is used, actually, if you see an NOC, Network Operation Center, they have in banks and these big places, you'll find a lot of people sitting, youngsters, they're watching some big TV. You can replace all of them with software now. So that can be done. Okay, these are the processes, etc. And Twitter is, you got this Twitter Storm, which is a software. And you have this LinkedIn, Samza, which is also checking all your messages and profiling them and really trying to find in real time what is popular, which is causing more activity. I mean, what kind of people are getting excited about what kind of event, and those kind of things you can get. Can an auditor use it? If it's an consultancy role, yes, assurance maybe not much, but consultancy, a lot of insights can be built up. The MapReduce is, of course, the one that is summarizing this, counting, summing. It look more like an Excel, collating, filtering, parsing data. That's data cleansing, I would call it, rather than validation. Distributed task execution, that Excel cannot do, but okay, can be done because of parallel processing. It can sort large amounts of data in peculiar orders. Say in a certain order, but I didn't put peculiar, but you're not looking at it date-wise or age-wise or name-wise. You may be looking at it as in some other form where whether a particular name and a particular product are going together. Now, sometimes it's what sense does it make? But when they start doing those kind of things, you find there are patterns, and that helps a lot when you are doing this sort. In fact, what they, I mean, it's an old case, I mean, actually it's a textbook example. If you put the baby diapers and the beer cans together, it's in the US, and the customer is babysitting for that, whatever that night, he'll buy the diapers and then he'll buy cans of beer and go. Now that's in the US. But if you see in India, by purchase patterns like hoarding, buying large quantities of something, we get a lot of data, and by sorting, we're able to find out consumption of sugar has dropped in India drastically. Bengal is the highest consumption, but other states have dropped. Mainly, it's not so much the diabetes, it was originally, but now it is that people even without diabetes are controlling their sugar. Maybe don't want to get fat or whatever the problem, except the software guys, all of them are dropping the sugar consumption. Now your sugar is finding its place in products like cool drinks and sweets. They're not selling sugar as sugar, but everything else you eat is probably got sugar on it. Then iterative message passing, that's a graph processing. If you have time, you can read graph databases, but don't worry too much. Go one step at a time. Start with SQL, then one step at a time. Then unique item counting. Now this is where your set theory works. Do it in SQL because it's a lot easier there. Left join, right, inner, outer, etc. Cross correlation, we call it as clustering, collaborative stuff. You can do it in statistics, but again, I'm just finishing the class, but don't worry too much about learning everything just overnight. You can take your time. Now, geospatial is important because we are now based on locations. And locations is not tourism, it's not petrol sale, it is not only that. It also means where people congregate, where people would like to go. Now, lot of data flows in, which can give you a lot of insights. Now, actually, to be frank, we talk about pilgrim tours, very famous. People go on pilgrimages. But India is also a large destination. It's called medical tourism, where people come as tourists, get on medical surgery or operation or something done, and they go back. Because you came here as a tourist and had a medical emergency, you had the emergency, but you didn't disclose it. You are eligible for insurance in your home country. So medical tourism is pretty huge in India. So how do we know that? Because you're doing a geospatial analysis and then you figure out what's happening. Okay, and I just took one example here. You can, if you have time, just go through this, but I'll also show an example. Now, graph databases are all lines, nodes, actually, as they call them. You got a lot of these, Giraffe, Titan, Faunus, etc. Now, what they do is they try to put those edges and points together so that we observe patterns. We have an example here. Now, this chap is a data-driven marketer, of course. He's highly qualified, of course. But anyway, now what he does, this is his own data. Only first he knows data. Now, where he studied his MBA is one cluster, his classmates, whatever. All this taken from Facebook, but now Facebook is asking for money if you want data. Earlier it was free, but now I have to pay. Then Washington University is friends. His management consulting is clients. And then of course his Kantar Health is where he's a consultant, is this group. Now what you find is his consulting thing is a bit kind of spread out. And his Washington University MBA friends are kind of creeping in. But this Washington University SAU is very closed, and this Kantar Health is also very closed. Now he's segregated these people, and then he's trying to see who is linked to whom. Actually, same thing is done by the US consulate when they check for visas. But anyway, they won't tell us that, but that's what they do. And by segregating these groups, you'll find groups which are widely dispersed, groups which are very closely grouped together, clustered together. And from this, you know that a chap in Kantar Health will not talk to anybody in this Washington University. So if you're sending an email, no point sending to both of them the same mail, no responses. Customize it for these people separately, customize it for these people separately. Of course, he's doing marketing, but it can be anything. When you do fraud analytics, related parties, conflict of interest, vendor kickbacks, these kind of spread is very important. You have an employee who's also in the Rotary, and he's got a supplier who's also in the Rotary. You got some problems there. So those kind of issues where the spread gets mixed, like our COVID clusters, weddings, funerals, clustering. Nobody wants to go anywhere safe. It works that way. This gives you a, don't worry about the 2013, this gives you a complete summary of all the databases. So this this is the key. Okay, the main one in the white is our traditional databases. And then you have the different colors which are giving you the MongoDB and so on, the IBM part. And this side, the blue color, we have got the other databases. And on top here, we have the rest of them. So if I just zoom in a little bit, you could see that the traditional stuff I was talking, SQLite is sitting here, but that's okay. Then we have this MySQL and so on. I'm sure you've seen all these stuff. But these are the ones which get a little bigger, like we got this TIBCO, Oracle, etc., getting a little bigger. And then this side we have the more specific use ones, where they are more specialized. Like we have Watson, we have this Titan, Giraffe, which I was telling you. They're more use specific. This is larger. This is the common. And of course, here we have the very complex ones like your Google engines and compute engines. Of course, you have Google Analytics and all we have, but it's an old one. It get updated. So here you have all your general purpose, etc., etc. Try to go through these things because they're quite helpful as we learn more and more. Now, the last example I'm taking is in the US, they have managed to put this data on population, where they know whether they're in the house or outside, who their neighbors are, where do you travel. Again, this privacy issue will come, but that's okay. That's based on the law. If you want to do it, you can do it as long as the law doesn't prevent it. So what happens is you get a complete household information and person population. So the thing is, we do an annual census, not annual. Every decade we do it, every 10 years. Now, US also used to do it. We learned it from them, but they don't do it anymore. Your population data is in real time now. If you don't come out of your house for more than certain hours, then they'll check on you whether there's a gas leak or somebody fell down. I mean, particularly old people. I mean, various issues. A picture may not be very clear. So I'm just trying to. It's a cut paste from the internet. Not very good if you ask me, but okay. So what it does is it takes this microdata household viewer and gives you everything you want: background layers, demographic layers, squad layers, etc. So what are we trying to do? Are we trying to snoop on people? No, this is the fire service or the police will know immediately if something is not happening or somebody is not moving. We'd like to know what happened. This is a website for that. Okay, so you can see that. So what you're maintaining your population in real time. I mean, population statistics is maintained in real time. These are the kind of maps, same thing with same population stuff. Okay, this was a SkyKit algorithm. So just put it there. I mean, those of you finished with SQL can slowly start going into Python. R is more of statistical stuff. Python is a lot easier for the financial people. They have packages like TensorFlow and SkyKit and so on. You can use a lot of functions. You have classification, your regression, clustering. Okay, well, what we are basically saying is, if I finished with SQL, which is more like audit objective, you have to decide. Now here, when you run it through these tests like KNN, okay, K nearest neighbor is KNN. We have this naive Bayes theorem. You could have whatever logistic regression. You may find it somewhere here. I don't know where to find it, but okay, somewhere here it will be there. Or you may look at random forest or something like that. I mean, a lot of things you can do like simple vector machines and so on. What you will find is you can do a lot of there in the SQL. We had to have the question. We are looking for the answers. Now you take the data and run it, and obviously the mismatches and outliers and patterns which are not out of this normal pattern, data automatically gets thrown up. So it becomes a lot easier for the auditor to come to conclusions. And this is also of particular use in statutory audits, because when your data gets larger, okay, we have been having a few rules, but then they withdraw it or sometimes they delay. NCA, SEBI, mainly for companies, income tax, GST. GST headache, and you got to match 1-to-1, same like our income tax. All this will throw out all the mismatched items, but you have to learn. I mean, it's a little bit of learning of not the SkyKit, it's more of the statistics. Is what is classification, what is clustering, and so on. Again, don't read any big complex mathematical statistics book or business statistics book. Just read a simple book, like beginner's book. Enough, we come standard more than enough, we'll manage. Don't learn any formula. All this is built into the software. Just use it. That's all. Okay, so I'd like to thank you, and if you have any questions, I will answer them.
Yes, sir. We have these 3 questions too.
Yeah. SQL is more data. Yeah, obviously, because what happens in SQL is your data has gone into a database, which is more of access control. In Excel, what happens is it doesn't have to be a fraud. It's accidents also. Somebody moves the cursor wrongly, taps the wrong key, saves it, makes a mess of it. SQL has no data integrity, but your database where you dumped it, your MySQL or SQLite, that has got access controls. And second thing, we don't touch the data, you only extract, you select or insert or update or something. Excel is actually, I'm going to give you the background. When Microsoft BI came, they wanted to replace Excel, but Excel had such a large user base. Microsoft, then last minute they decided Excel will continue. Microsoft, it's called Power BI, will also continue. But the DAX which they developed for Power BI is now available in Excel. They ported the other way around. So it's there, Excel is there, but try to move out of it slowly. Then Storm Engine, reducing traffic congestions, yes. You have to stream. Actually, the whole thing is, if you notice, the number of rail accidents have come down because you're using axle counters. If you're a frequent train traveler, at either end of the station, before you reach it and after you leave it, there are what are called cabins, outer cabin, inner cabin. They're almost demolished now because they don't use it anymore. These axle counters and the signaling equipment, IoTs, of course, not the greatest in the world. I mean, that's also I'm telling you. But if you peep into one of those station masters' rooms, you'll see a lot of lines and lights, and that is becoming automatic. That is how you are getting real-time rail movements on your phones or your internet. Traffic congestion on airline is absolutely necessary. Motor vehicles, the problem is the drivers. We have a lot of rules, but nobody follows it. And most of the Indian accidents are because they didn't follow rules. Of course, we have reduced a lot actually. In Tamil Nadu, last year, I think, or this year, 1,600 people died. That is not a big number for India's population, but it is a number. I mean, and they say most of these two-wheeler deaths are because of no helmet. So these are all the issues. Parsing means you take a string of characters and then you read through it. The concept of parsing is very common in modems or in spreadsheets. Let's say data is coming in a modem and it's also bringing noise characters. That is, apart from alphabets and digits, it's also carrying special characters. So you take each character, check if it is within, let's say for ASCII, we say 32 to 97. 32 to 97 are the normal characters. Anything else is a special character. We discard it. So the moment you discard the special character, you are filtering the noise. Or in a parsing, if you are importing a string into Excel, it will come into a single column. Then you'll have those greater than signs or exclamation, whatever. You map that and take the fields out. Or in a CSV file, if you find commas, when the comma comes, all data before it is the data for the field. And then after the next comma, till you find the next comma, whatever you read, that's the data for the second field, and so on. So when you parse, you will be looking for something, special characters, punctuations, something like that. So that is what you mean by parsing. So when I say import a CSV, I said CSV because it's a comma separated file, but Unix will produce any kind of file, hash separated, tab separated, it's called white space. or you may get a colon, you may get a semicolon. It depends. Okay, so that's parsing. Now, if a CA wants to go into data science, see, the most important thing is before the course, you need to first see whether you like mathematics and statistics, because the salary depends on what we are able to contribute. Now, we used to have a lot of maths in the CA course at one time in Inter, and it's gone. It went to foundation, disappeared. It's not very great now. If you don't like mathematics and statistics, a career in data science will be very difficult. But if you like it, I mean, if you like this data, whatever, maths and stats, then definitely you can work your way up. There's no problem at all. There are plenty of data science courses starting from Udemy or the online ones up to colleges, universities, and in the SWAYAM, which is the NPTEL, that's the Government of India's initiative. IIT professors take classes, but only thing it's you'll have to answer all those questions and take an exam. Exam fee is only 1,000 rupees. Course is free. So the next SWAYAM course you can enlist for something, data science or Python or whatever. Exam fee is 1,000 if you want a certificate. If you don't want that, even that you need not pay. Just give it a try. If you think it's like your cup of tea, yes, not a cup of tea, then it won't work. I suggest SWAYAM courses because it's the cheapest experiment you can do. Okay, so I think I've answered all these questions here. Is there anything else? NPTEL, SWAYAM, SWYAM. Okay, just put that. Of course, all courses have already started now. The next set of courses you can just enroll and see how you like it. Take one subject and give it a try. You can take Python, you can take data analytics, you can take whatever you want. I think if you have no more questions, then I think we can wind up for today.
Selva, is there any other question?
No, sir. Those were the questions.
Okay. So thank you, sir, for an interesting 3 hours of session. I think there are a lot of inputs to all of us. Thanks a lot. I know amidst your busy schedule for having come and spent your time with us and share your knowledge. Really thankful to you. On behalf of the SIRC, the chairman is not there today. So I place my heartfelt gratitude and thanks to you for making the event a great one. Thank you, sir.
Thank you. Thank you very much. Thank the participants, SIRC. Thank you and wish you all the best. Thank you.